our what? Anybody? Yes, thank you. Our aurora borealis and our aurora australis. Now, there is always solar wind coming from the sun, which is deflected by the magnetic field as well. And I should say that my PowerPoint and all the movies, if you want it, you can have it. Another group is the Mars and Planetary Science group. These guys, of course, are looking at the planets and trying to answer the questions. Are there others out there? Is there life out there? What's going on with these planets? And so one of our newest missions, which hasn't even gone up yet, is the Mars Science Laboratory, which is named Curiosity. It's basically another rover, however, it's a pretty large rover, and it has a full lab on board. It is going to be able to do a lot more analysis than the rovers that are there now. And so Curiosity is scheduled to launch somewhere between November 25th and December 18th. We don't have an actual launch date yet. And if it launches within that window, it will arrive August 2012. It is going to land in an area where there is a huge crater that has an alluvial fan. And then if you know a little bit about Earth science, you know that that's the area where water runs down and the sediments collect at the bottom of a hill or a mountain. And so within that area, there have been evidence for clays and sulfates there, which are things that are formed only in water. So if there was life on Mars at one time, or if there is still microbial life, this is a good area for it to go and look. And so this is the artist's conception of Curiosity's landing. Curiosity is going to land differently than the other rovers. The other rovers were inside of like an inflatable ball, and they bounced and bounced and bounced and bounced. This craft is so large, it actually has its own jets that is going to safely put it down on the ground. We hope. If everything goes well. So far, JPL has been really lucky with its stuff going to Mars, so I don't see any reason why this will not go this way, hopefully. And then once it gets on the ground, it's going to start rolling around and checking things out. Now, this is a animation that I put in here just to give you nightmares. No other reason. This is really good for scaring your kids. No, this is a very good, lost my train of thought, isn't that awful? This is a wonderful animation, but it's using real data. Every one of these green dots are asteroids within our solar system. And if you look at the center, there's our sun. Look at 3 orbits out. That's Earth. Look at the green dots. There's the nightmare. Because when we went to school, at least when I went to school, I was taught, I'm telling my age, that the asteroid belt was between Mars and Jupiter. So I thought that meant all the asteroids were between Mars and Jupiter, because no one bothered to say that. Oh no, the majority of them are between Mars and Jupiter, but there are asteroids everywhere. And so as you can see, there are asteroids everywhere in the solar system. They fly by all the time. We monitor only 2% of what's out there. That's a very small percentage. However, we're okay for, at least a 36 or so. Unless there's some rogue that we don't know about. So to me, this is like a great data image. Show to Congress to get funding for more space observation. So the astrophysics group. One of the things I was asked was to talk to you about how to bring astrophysics into your classrooms, because the name just sounds scary, but it really isn't. And the astrophysics group, they're trying to answer questions that I personally do not want to know the answer to. Questions like, what is going to happen to the universe? Is the universe going to continue to expand to the point where no planets are near any stars and they all just go cold and everything dies? Who wants to know this? I don't want to know this. You can't prepare for that scenario. So The James Webb Telescope was due to go 2013. Because of funding and the crisis in the country, I doubt very seriously it will leave 2013. But hopefully between 2013 and 2016 it will go up, because Hubble is getting very old. Though Hubble has given us a wealth of knowledge and wonderful, wonderful images, this telescope is going to take us much, much further out into space. They're talking about being able to see light at the beginning of the Big Bang with this, which is amazing. So you're going to be able to detect light from the very beginning. This is also another huge monumental task. This telescope is going to be placed 1 million miles away from Earth in orbit around the Earth. That will be the furthest thing we've ever placed in an orbit around the Earth. So there's another milestone there. And the the James Webb will be looking at things in different wavelengths of light, which is why I have this here. Because this is an image that if you look at it, oh, it looks very pretty. And that's what people would say, but they don't understand how much information is here. And as a teacher, even kindergarten, you can use this poster. And I also show this because I have about 80 more copies of this poster, which is about half the size of this screen here. And then they're gone forever. They're not going to print anymore. So, on your tables, there are some blue papers, which if you would like to leave me your email address or your address, I can mail you that. Your email address will get placed in my database, which I send out when there are opportunities at NASA. I don't send you junk mail. I don't put you on the master serve list. It's just mine. I filter heavily. So you may get 3 emails a year. So just throw that out there. But looking at this poster, I just want to tell you about it very quickly. If you look at the different wavelengths of light, this is our solar system. This is our solar system, the Milky Way. And looking at it edge on, it's the only way we can see it because we're in it. We're in the spiral arm, and our galaxy has a central bulge and the 2 arms out. And we're out here in one of these arms. And so this image was obviously not taken in a night. This was taken over a year, and all these images put together to give us the best image that we could have of our solar system. Of course, there's some gaps, and we filled those gaps in, but it's the best image we have. But when we look out at our solar system with different types of electromagnetic radiation, and what I would tell kindergartners, eyes, different kinds of eyes, our eyes see one kind of light, and we need other eyes that can see different kinds of light in order to get a complete picture of what's there. And so when we look at this in the optical, through the middle of optical is black. So what would we say is there? What's that word we would use? Thank you, that's the one. I don't know when and where in life we were all taught this, but someone told us that black meant nothing. I don't get it. And it's so funny too, because ask someone to open a door in a dark room and ask them what's in that room. If it's dark, they'll tell you nothing. You know there's something in the room. But it's an idea that we have, and it sticks with us. And so if we look only at optical, this is what we would assume. There's nothing in the middle of the whole solar system. And it's not true. Because as we look down in X-ray and gamma ray, things pop out. And if you can see in the center of our galaxy in the gamma ray, you see something that pops out in the center that's very bright. And that something is a black hole. A black hole, this is where it gets a little complicated. Nothing escapes the black hole, true. So there should not be any light seen, but what you're actually seeing is the black hole feeding on its twin. And you're getting a gamma ray burst from that happening. So anyway.